Hello everybody. In this algebra review, we'll be talking about radicals, the first concept being simplifying radicals. So simplifying radicals means breaking it down so that universally we have one way to represent that number, okay? Because think about a fraction, 1/2, we could represent that also as 4/8, 3/6, 10/20, but universally we simplify that so we all know we're talking about 1/2. That is a simplified version. It's the same thing with radicals. And something that's going to be really important to help us is knowing our perfect squares, 1 through 15. We should know those. We should know the squares of all of those numbers. All right, so 7 squared, boom, we should know 49. 11 squared, boom, we should know 121. Okay, so let's talk about this process of simplifying a radical. And it's going to be really similar to trying to find the factor tree of 40. But this time, 40 is underneath a radical. So we're going to break it down similarly to a factor tree. We just have to remember that these are square roots because there's a property that says if I take the square root of a times the square root of b, that's the square root of a times b underneath that radical. So what that actually is talking about, if I have square root of 3 times the square root of 5, that's the square root of 3 times 5, which is the square root of 15. Okay, so we can break down a radical into its different quote-unquote factors. All right, so let me clear this space because we're going to need it. All right, so square root of 40. What breaks down into square root of 40? Well, I know 2 does. 2 goes into it 20 times. I can't break down square root of 2 anymore, just like we couldn't break down 2 if this was a factor tree. Square root of 20, square root of 2 times the square root of 10. Again, can't break down 2. Square root of 10, square root of 2, square root of 5. All right? So square root of 2, square root of 2, square root of 2, square root of 5. End of my branches, I could rewrite square root of 40 as the square root of 2 times 2 times 2 times 5, or the square root of 2 times the square root of 2 times the square root of 2 times the square root of 5. All right? And now comes where we need to know our perfect squares. Okay? None of these are perfect squares. 2 and 5 are not perfect squares. All right. However, if I multiplied square root of 2 times square root of 2, that would be square root of 4. And square root of 4, right here, square root of 4 is 2. Working backwards there. Okay. And then here, we have square root of 2 times square root of 5. Well, those come together to give me square root of 10. That is not a perfect square, and there's not a perfect square hidden within 10. So that has to stay under the radical. All right, so square root of 40 simplifies to give me 2 square roots of 10. Another way I like to think about this is that if things have a buddy, square root of 2 has a buddy right here. If it has a buddy, it gets to come outside. The number gets to come outside. Anything that doesn't have to have a buddy has to multiply together and is stuck underneath the radical. All right, so let's do another example, square root of 96. So 96 is even, so I know 2 goes into it. 2 goes into it. Oops, sorry. 2 goes into it 48 times. Neither of those are perfect squares, so I'm going to keep going. Square root of 48 is also even, in that 2 goes into it 24 times. This is also even, so I know 2 goes into it, 2 goes into it 12 times. 12 breaks down into 2 and 6. 6 breaks down into 2 and 3. All right, so now we look at the end of our branches and we try to see what are buddies that get to come outside. So here's one pair of buddies. So 1, 2 gets to come outside. Here's another pair of buddies, so another 2 gets to come outside. Now this 2 and this 3 do not have buddies, so they are stuck underneath the radical. All right, so outside 2 times 2, that's 4. Underneath the radical, square root of 2 times square root of 3 is going to give me square root of 6. Okay, next is 288. 288. So, again, even. So I know 2 goes into it. 288 divided by 2, that's 144. Now, as we start to do more and more of these, you're going to recognize that this is a shortcut that you can use. Look while you're working on branches and try to figure out, is there a perfect square that goes into this number? Square root of 144, right here, square root of 144 is 12. So I can stop here, okay? Because square root of 144 is going to simplify to 12, and this square root of 2 is stuck underneath the radical because it does not have a buddy. All right, so that is simplifying radicals. You can, like in the first two examples, you can keep break down until you're in its, quote, prime factorization, and then the buddies get to come outside, whatever doesn't have a buddy stuck underneath. Or, like in the last example, you can try to find a perfect square there. All right, so for example, like if I go back to square root of 96, well, let me see, here's a perfect square, 4. Let me see if 4 goes into 96. So I take 96 divided by 4. It does, 4 times 24. So I'm going to stop here because I know what the square root of 4 is. 24, let me see if another perfect square goes into it. Yes, 4 goes into it. So I can stop here. Is there any perfect square stuck inside 6? Well, no, 6 breaks down into 2 and 3. None of those are perfect squares. All right, so I got square root of 4 times square root of 4. So that is 2 times square root of 6, which is 4 rad 6. All right, those answers match. So there are multiple ways where you can simplify radicals, and this is a skill we will be using a lot in honors geometry. Okay, so it's important to pick a method that's going to help you. And if you need help on these, because they do require practice, this concept of like a prime factorization factor tree, but then pairing up buddies get to come outside, anything that doesn't have a buddy stuck underneath the radical, it will require work. It will require practice. So make sure you do that. And if you have any questions, you let me know. All right, in the next video, we will talk about how we solve quadratics using square roots. But for now, just practice simplifying radicals.